Hi, my name is Oktay. This video is about the top 10 nearest star systems. We start a journey from Earth, beautiful blue marble, diameter 12,742 kilometers. It's 150 million kilometers distance from the Sun, and that's about 8 light minutes. Number one is, of course, the Sun, center of our solar system. It's the source of life, the G-type star, diameter 1.39 million kilometers. The mass is about 2 times 10 to the 30 kilograms. Surface temperature is 5,500 degrees Celsius, at the core 50 million degrees Celsius. The energy is provided by the fusion reaction of hydrogen to helium. The Sun's and the solar system's age is about 4.6 gigayears, 4.6 billion years. Sun orbits the galactic center at a distance from 26,000 light years. Orbital period is 226 million years, and orbital speed is 230 km per second. This is a picture of the sunspots. There is an activity cycle of 11 years with a maximum and a minimum, and each of these spots has about the size of the Earth. This is very interesting. It shows the classification of stars. Sun is the G star here, and you can see the bigger stars are very rare. Most common star type is the M star, that's called red dwarf. 76% of all stars, and there's another type of stars in between that's called orange dwarfs, that's the K stars. They have about 12%. The Milky Way has about 100 to 400 billion stars. It's not easy to determine because we are right in the middle of a disk of 1,000 light years thickness. We don't have the perfect perspective to measure the number of stars. And there's a sentence that you can use for memorizing all these star types. That's "Oh, be a fine girl, kiss me." Oh, be a fine girl, kiss me. This is a picture of the Hertzsprung-Russell diagram. The x-axis is temperature, y-axis is luminosity. This is animation of a part of this diagram. It shows where all the star types are, and it shows the future of the Sun. At her birth, the Sun had about 70% of today's luminosity. Every 100 million years, the luminosity goes up by about 1%. And this is what will look like in 12 billion years. And eventually, the Sun will lose half of its material to space. And the other half will shrink to an object called white dwarf. And it will have the size of about the Earth. Today, still 91% of the atoms in the Sun are hydrogen and 9% are helium. This is number 2 nearest star, Proxima Centauri. This distance is from the Sun 4.2 light years. Has 14% of Sun's diameter and 12% of its mass. It's about 1/4 billion years older than the Sun. It's an M dwarf, a red dwarf. And it's a part of a triple star system. It is about 0.2 light years away from the main 2 big stars of this triple star system, Alpha Centauri A and B. Its orbital period is about 500,000 years. And luminosity is 0.16% of that of the Sun. Proxima Centauri is known to have exoplanets. One of which is a very interesting candidate. This computer animation how it could look like. It is about 0.05 AU, which is very close to its star. But the star is a dim star, and that's why it's still in the habitable zone. There's about the same mass as Earth. And there's another candidate which is 7 times Earth's mass. And the third planet which is outside of the habitable zone. And this will be very interesting to see how Earth-sized planets around red dwarfs look like. It could be that some could support life, but it could also be that none of them support life, because since the star is so close to its planet, it could erode all the atmosphere with the stellar winds. A dust belt was found around Proxima Centauri. This could be an indicator for a planetary system. And this star, Proxima Centauri's lifetime is estimated to 10 trillion years. That's 10,000 billion years. This is number 3. It's the pair Alpha Centauri. They're about 4.4 light years away from the Sun. They're much older than the Sun, and they orbit each other at a distance from 11 to 36 AU. For comparison, 11 AU is about the distance from Sun to Saturn. And the Alpha Centauri A star is a heavier G star. It has 8% higher mass and 1.5 times the Sun's luminosity. And its surface is 5,500 degrees Celsius. The second star B is a K star. It is smaller than the Sun, has only half the Sun's luminosity, and is a bit cooler. This animation shows you the movement of Barnard star over 9 years. Barnard star is 6 light years away from the Sun. Age is 10 gigayears. And it's another M star, which is a red dwarf with 14% of Sun's mass and 20% of its diameter. It has only 10 to 32% of Sun's metallicity, because it's an old star. There's a relation between the metallicity of a star and its age. Astronomers have a different definition of metallicity, and chemists. For an astronomer, every element other than helium and hydrogen is a metal. So, for an astronomer, oxygen is a metal, carbon, nitrogen, phosphorus, iodine. And this star is a fast-moving star, and moves at 110 kilometers per second relative to the Sun. This is the number 5, Wolf 359. It's about 8 light years away from the Sun. It's a young star with age about 100 to 350 million years. And it's a flare star. This means this star has outbursts of matter and charged particles. It is a 11% of Sun's mass and a little fraction of the Sun's luminosity. And it also has planets, but none of them, none of the two is in the habitable zone of this. This is Lalande 21185. Its distance from the Sun is 8.3 light years. Its age is 5 to 10 gigayears, 5 to 10 billion years. It's again an M dwarf and a flare star. It is more massive than Barnard star, at about 39% of Sun's mass and 39% of its diameter. It has 3 planets, one of which is about Earth size, that's planet B. The other one is about Neptune size, that's planet C. And there's another third candidate at 0.5 AU. And none of these 3 planets and candidates are in the habitable zone. Probably this planet B is too hot for it. This is number 7, Sirius. A pair of objects that are 8.6 light years away. Its age of the system is 230 million years. Distance of the 2 components A and B varies between 8 to 32 AU. Period is 50 years. Sirius A is a more massive star than the Sun. It's an A-type star. There's 1.7 times the diameter of the Sun, double the mass, and 25 times the luminosity, which makes it the brightest star in the night sky. The Sirius B is a white dwarf. It has more comparable the size of the Earth than the Sun, but it has about the mass of the Sun, and that's a tiny fraction of its luminosity. This is number 8, Luyten 7268. It's at a distance of 8.7 light years. Its age is unclear. This is a pair of M stars, red dwarfs. They're again flare stars, about the same size. They're 14% of Sun's diameter and 10% of its mass. And again, just a fraction of the Sun's luminosity. This is Ross 154. Its distance is 9.7 light years. It's a very young star. It's less than 1 billion years old. Surface temperature is 3070 degrees Celsius. It's a flare star. Its diameter is 20% of the Sun, and 18% of the it has 18% of the Sun's mass. And it is named after Frank Elmer Ross, who catalogued the star in 1925. Since this star is young, it is metal rich. That's called a population 1 star. This is number 10, Ross 248. Its distance is about 10 light years from Earth. It has about half the Sun's age, 2.6 giga-years. It's again an M star and a flare star. Its size is about 19% of the Sun, mass 15%, and is a very dim star. This star was also catalogued by Frank Elmer Ross. And one interesting thing is this Ross 248 star is moving towards us, towards the Sun. And it will approach the Sun to 3 light years in 33,000 years. This is very interesting. It shows the movement of the stars over the time. So x-axis is 1,000 years time, and the y-axis is the distance. And you can see the movement of the stars is has less order than, for example, the movement of the planets around the star or around the Sun. And right now, the Proxima Centauri, Alpha Centauri are the closest stars, but they will eventually drift away. This is Ross 248. It will approach in about 33,000 years. And there's another star, Gliese 710. That's a K star. Today it's at 62 light years distance, but in 1.3 million years it will come as close as 0.17 light years. That's just 10,750 astronomical units. That's very close. That's within the Oort cloud. And this star could disrupt the Oort cloud, and several objects could be deflected to the inner solar system. Yeah, this could lead to potentially dangerous situations. This is an example of another star that's further away. That's on the big side of the stars. It's Stephenson 218. It's at a distance of 18,900 light years. There's a mass of 12 to 16 times the mass of the Sun. Its radius is 10 AU, astronomical units. This means if this star was in the center of our solar system, all the terrestrial planets and Jupiter and Saturn would be still inside the star. That's how big it is. And its luminosity is 437,000 times the luminosity of the Sun. And that's another very important factor for life. We have no big stars that are potentially dangerous in our stellar neighborhood. We have only smaller stars, most except Sirius A. And that's another very important requirement for life, because there are no supernova that could destroy Earth, potentially destroy Earth's atmosphere. That was today's video about the 10 nearest stars. Thank you for watching. Have a nice day. Bye-bye.